Hi everyone, I'm using this extra video to show you another example about induction. I have talked to a couple of you guys and it seems that you are struggling a little bit about the induction. And in this course, we are going to use induction several times to prove the time efficiency of some of the algorithms. So I want to make sure you understand how does induction work and then how do you solve the problems using induction. Okay, so let's have a very quick review about induction. So for the induction, we are trying to prove that a statement is true for n values greater or equal to a k. Okay, and then there are three major steps. So number one, the basis. For the basis, you want to prove that for the value k, well, this statement S is true. Okay, so you want to prove that. And the second part, it is the inductive hypothesis. Well, for this part, you don't have to prove anything. You only want to assume that, well, this Sn is true for a given value n. And based on that, the next step, which is a crucial step, you want to prove that it is also true for n plus 1. And the idea is, if you say, okay, starting from k, it is true. And combining the second two steps, if n is true, and then for n plus 1, it is also true. And so, if we start from the k value, if for k it is true, and then for k plus 1, it is also true. And if we move one step forward, and because of the fact that for k plus 1 it is true, if we increase by 1 again, so k plus 2, it is also true. And then we can go on and on and on, and we can prove that it will be true for all the values when n is greater than k. Okay, so let me show you the example. This is a question I made by myself. Okay, oops, I made a mistake. I want to say 50 instead of 5. Okay, so our goal is we want to prove 50n. Oops. Okay, we want to prove that 50n is smaller than n squared when n is greater than 51. So, well, I think the number one question is why do we want to choose the 51? Okay, let me show you a table. Say, if we want to do a 50n versus the n squared. And let's start from the n value as 1. So when n value is 1, we have 50, and then 1 squared, which is 1. And then how about 2? So we have 100. And then, well, we have 4. Okay, still kind of far away. And then how about 3? And 150. And then we have 9. And then if you have 4, n is 4, and then we have 200. And then we will have 16. Okay, so what do you feel? You may feel that, well, for the column on the left side, 50n, they are pretty big values compared with the n squared. But for n squared, do you see some of the promises? Because, well, if you see the increases of the values, well, this column increases faster than 50n. So what is going to happen? So eventually, we are going to have a linear increase for the 50n. And then how about n squared? N squared, we are going to have this kind of a quadratic increase. So even though we started slow, and then, oops, 50n, not 5n. Okay, well, even though n squared started, come on, okay, even though n squared started slow, but eventually n squared will be faster. And then when will this happen? Okay, so how about we write down 50? When n value is 50, and then 50n will be 50 squared. And then how about n squared? Okay, this is a 50 squared again. So now, when the n value is 50, guess what? Those two curves, they will meet here, and the value is 50. And then how about 51? For the 51, okay, and then we have the 50 multiplied by 51. And guess what value do we have on the right side? We have 51 squared. Okay, so this means after n, at least when n value is 51, what we will see is, well, n square will, oops, come on. And when n value is 51, and this is the basis, so n equals 51, and then we will have 50 multiplied by 51 is smaller than 51 squared. So at this point, so this statement is true. So the statement is true. Okay, so this is the basis part. And the number 2, we want to do a hypothesis. So inductive hypothesis. So assume we assume that for a specific n value greater than 51, and then 50n is indeed smaller than n squared. Okay, so we only want to assume that it is true. We don't want to prove anything for the second part. And then the third part is we want to prove for n plus 1. Okay, so that is 50 n plus 1 is going to be smaller than n plus 1 squared. Okay, so this is the part we want to prove. We want to prove this is true. So how do we do that? So first, let me get rid of the part on the right side. I'm going to use that space later. Okay, so how do we prove this part? Okay, and how about we break it into, well, we get rid of the parentheses first, and that's usually a good thing to do. If we want to prove this, and then it's equivalent to, we want to prove 50n plus 50 is smaller than n squared, and plus 2n, and then plus 1, right? Because this part is exactly the same to this part. And on the right side, n plus 1 squared is exactly equal to this part. Okay, and then the next thing is, well, we know 50n is smaller than n squared. So n squared is larger, 50n is smaller. And next step, how about I get rid of this value and this value from the both sides? So it's, well, 50n is 50 is smaller than 2n plus 1. Because if we want to prove this part, and then I get rid of a larger part, n squared, on the right side, and 50n, which is small part, on the left side, if this part still holds, and then that's good. Okay, and then how do we move on? Well, if we want to prove that 2n plus 1 is larger than 50, it would be better if we also drop the 1 if we can prove that 2n is greater than 50. Okay, because I drop one positive value from the right side. If I drop the 1 and then it is still 2n is greater than 50, that would be terrific, right? And let's do one step further. If we can prove that 50 is smaller than n, that will be even better because I don't have to multiply this n by 2 if that n itself is already greater than 50, and that will be good. And guess what? This line, that is obvious. Why? Because we say, well, for n greater than 51, it is true. If n is greater than 51, and then, of course, n is greater than 50, right? Okay, and you may say, hey, professor, is that the full proof? And no, it's not. Well, this is my thinking process on a scratch paper. And after I have figured this out, and then I want to put everything in the reverse order. What do I mean? Okay, let me write down my proof. Well, I want to prove that we know n is greater than 51, right? So we started from the known part. And then we can say, so n is definitely greater than 50. Okay, is that true? Okay, and then, so 2n is, of course, greater than 50, because if n itself is greater than 50, and then 2n is of course greater than 50. So we started from the obvious thing, and then we move down. And then where am I going? And then we say if 2n is already greater than 50, and 2n plus 1 is of course greater than 50, because I'm adding one more value, one more positive value to the left side. Okay, and then we also know, well, n squared is greater than 50, so how about I add a larger value, n squared, to the left side, and then we add a smaller value, 50n, to the right side. Okay, so on the left side, I added n squared, which is larger value. On the right side, I added 50n, which is smaller value. So yes, and then n plus 1 square is greater than 50 n squared. Sorry, 50 n plus 1. Okay, so this is exactly we want to prove. We want to prove that for n plus 1, 50 n plus 1 is smaller than n plus 1 squared. And then I just prove that, which is this part. Okay, so this is the process of doing the proof. And eventually I don't want to mislead you, and then I want to get rid of the scratching part. Okay, so this is how to prove the third part. And from the third part, we want to start from the things we definitely know, and then we move on and on. We build, and then we eventually want to show this part, and this part is exactly this part we are trying to prove. So this is just a small example about how to do inductions, and I hope this can help. Okay, if you have other topics you want to see another example, let me know.